All right, we're going to start off where we left off, the extra practice. It says, let's say you're testing two flu drugs, A and B. Drug A works on 41 people out of the sample of 195. Drug B works on 351 people in a sample of 605. Are the two drugs comparable? Use a 5% alpha level. Okay, so a sentence describing the parameter that is being tested. So, are the two drugs comparable? So N1 we'll call drug A. We'll refer to it as P1, and then drug B, sorry, as P2. Okay, so drug A, my sample size is 195. My X value is 41, and then my P hat, let me put that in the calculator, is 0.210. All right, N2, which is drug B, is 605, and then 351, and then let me get that P hat value, 0.580. We're not going to do this. Remember, this is step one. So are they comparable? So does P1 equal P2? And then does P1 not equal P2? All right. We could do some of this math. So for mu, we're going to do the difference. So 0.210 minus 0.580. And this is negative point. Sorry, let me fix that. I didn't put that 0 on the front. Negative 0.370. And then here, this is what I'm going to plug in the calculator. Oh, we didn't do p hat. Oh, here, let me run the program. So stats, go to test, to prop z test, number 6. And then x1 is 41, n1 is 195. X2 is 351, and N2 is 605. We're doing does not equal, calculate. Okay, so my Z is negative 8.986. My P hat is 0.49. And then I'm going to write my P value here. Oh no, that's not it. I didn't see the E. So it's basically really, 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 really small because that's 0. I'm just going to say it's 0. There's 19. It's negative 19. Okay. All right, that's all I need for now. So let's do 0.49 times 1 minus 0.49 times the square root. I'm going to put it down here of 1 over 195 plus 1 over 605. So let me put that in the calculator. 0.49 times 1 minus 0.49. And then times the square root of 1 over 195. Plus 1 over 605. And then this equals 0.041. Okay. So let's do the p-value. This is 2, this is 3. P-value versus alpha, and basically 0. Alpha is 5%, so 0.05. So who's bigger? Is alpha. So then we reject the null. So step 4, there is enough evidence to support the claim that the true drugs are comparable. Okay. Next one. Excuse me. A researcher is interested in knowing if male serial killers are less likely to kill someone they are related to compared to female serial killers. The researcher collected 146 victims for a male serial killer and found that 13 were related to their killers. The researcher collected 166 victims for a female serial killer and found that 93 were related to the serial killer. Is there enough to support the research claim? So the claim is, I'm going to copy it. Starts here, actually. Okay, I don't need that, but that came along with it. All right. So we'll say male is going to be P1, female P2, and these are serial killers. All right, so N1 is 146 and then 13, and 2 is 166 and then 93. So let me figure out P hat. .0.089, and then 93 divided by 166, 0.560. Okay, step 1, P1 equals P2. The alternative, it says, if male serial killers are less likely to kill someone they're related compared to the female. So probability of 1 is less than probability of 2. So I'm going to subtract P1 minus P2, P hat, sorry. So this gave me negative 0.471. And then I'm going to run the program. Remember, stat, test, 2 prop z test. X1 is 13, 146 for N1, 93 for X2, and 166. And then it's less than. Calculate. So my z is negative 8.769. And then my p hat is 0.33. Oops. 40, not 33. My p-value is 0. So just to find out sigma, so here I have 0.340 times 1 minus 0.340 times the square root of 1 over 146 plus 1 over 166. 0.340 times 1 minus 0.340, and then times the square root of 1 over 146 plus 1 over 166. Okay, so this equals 0.054. Okay, so p-value versus alpha. Okay, so they didn't give us alpha. So if alpha is not known, we always use 0.05. So alpha's bigger, so again, we reject the null. So 4, there is sufficient evidence to support the claim that male serial killers are less likely to kill someone they are related to compared to female serial killers. Okay, determining the sample size necessary for estimating the difference between two population proportions within a special margin of error. The sample size requires to obtain a 1 minus alpha times 100% confidence interval with the margin of error E. Formula when proportions for both populations is known. N equals N1 equals N2 equals all that. Formula if prior estimates of P1 and P2 are available. The sample size formula is N equals N1 equals N2, which is 0.5. Okay. So let's do the first one. Okay, and then for here, remember that you know P hat, and this one is you do not know P hat. All right, a doctor wants to estimate the difference in the proportion of 15 through 19-year-old mothers that receive prenatal care and the proportion of 30 to 34-year-old mothers that receive prenatal care. She uses the results of the National Vital Study Statistics report results in which 98% of the 15 to 19-year-old mothers receive prenatal care and 99.2% of the 30 to 34-year-old mothers received prenatal care. What sample size should be obtained if she wishes to estimate the estimate to be 2% points with 95% confidence, assuming that the data is normally distributed? Okay. So can we get p hat? So if we say 15 through 19-year-olds is P1, and then the 30 through 34-year-olds is P2. So P hat would be 0.98, which is given. P2 would be 0.992. And since it's known, I'm going to use this formula. So I'm going to say N is going to equal P1 hat, which is 0.98, times 1 minus 0.98, plus 0.992, times 1 minus 0.992, and then times Z alpha over 2 for 95% confidence interval. That's one of the special cases, so it's 1.96, sorry. Divided by the error, which is 2%, sorry, so 0.02. And this is squared, so let's plug that in the calculator. Oops, I messed up. 0.02. Okay, so this is going to equal 264.4, blah, blah, blah. So remember, we always round up, so 265. Okay, what sample size should be obtained if she wishes to estimate to be within 2% points with 95% confidence, assuming the data is normally distributed, but she does not use any of the prior estimates? So basically, we don't know p hat. So we're going to use the second formula, which is n equals 0.50 times 1.96 divided by 0.02, quantity squared. So put this in the calculator. This equals 4,802. Okay, so that ends 9.1. So finish assignment. I forgot the number. You guys know me already. Let me look it up really quick. Assignment 22. Numbers 5 through 21 odd. And then this will be due on Monday, 12/7. Okay, have a good weekend, guys. I'll see you all on Monday.